Hi, I'm Mark Wilson, the engineering heretic. Some 38 years ago, whilst I was living in Toronto, Canada, I acquired from an old toolmaker who was a friend of the family of my wife's this lovely old toolbox. It was full of tools. He was a toolmaker. His name was Charles Bowler. He lived in Hamilton, Ontario, and he was selling his tools, and I was fortunate enough to be able to acquire these, and I've had them in my collection, and they're very much a prized thing that I've had for the last almost 40 years now. One of the items that I have is this particular item here. This was Charles's here. There's one of his radius gauges, and this one here you can actually, if you can see the inscription of Charles Bowler on this. Some of my the parallel strips that I've got were also part of Charles's collection, so some of these are his, some of them are mine. But this particular thing here is a rev counter, and I'll focus that a bit. It comes, I think it's the original box. It has the original rev counter has this particular triangular thing on the front here, but this one comes with its original components with the rubber little things that you put on the tip of this. Now, on this particular one here, I'm just running out of hands here. I'll just put this on here. We'll shove it on there. Now, on this particular rev counter here, it's got it's a worm gear to driving in here, and it's a 100-to-1 ratio here, and you can undo this stop here and rotate that around and zero it out to the 0 point there. So I've got the little point thing at the moment, and I have a drill press with a belt drive on it, and we'll just go over to that and give it a go and see if we can determine what RPM that is actually running at. So, back in the days when you had overhead belts driving machines and probably a fairly unreliable, maybe hit and miss engine or even a steam engine, and of course you had overhead belts driving things on flat belts and different shafts transferring to others and things like that, it would have been almost impossible to know what RPM anything was doing at any one particular time. So to have one of these things here, this little rev counter thing here, was an essential thing. I suppose if the revs were going down too low, you could always go out to Joe out the back who's running the steam engine and give him a kick in the butt and make sure he shovels some more steam in the thing to up the revs of the whole shop. But you want to be able to prove your point, and sometimes having your cutter running at the right speed. Remember, we're in the days of some high-speed steel, but also some carbon steel, and carbon steel is like a file, and as soon as you get that to a certain temperature, it basically loses its integrity and stops cutting. So with old carbon steel and things like that, you needed a rev counter to know exactly how far you could push these machines before your cutter broke down. So this was used. Now this one has it's rubber stops. This is a Miller's Falls, I think it is. Made in the USA, and this is Charles Bowler's lovely piece of work. It's I've had it for nearly 40 years now. So let's do a little bit of a trial. We'll put it onto my machine, my drill press. This is a wall down drill. It's got a just a regular V-drive single pulley arrangement. It looks like it's doing something around at 500 RPM. It's as slow as it'll go. You could work it out exactly what the speed was if you knew the speed of the motor and the diameter of the pulleys. You could tell it straight away, but we'll do this with the old-fashioned way, and I suppose in the old days they would have had a fob watch or something like that. But what I'm going to do is I'm going to just bring this up here, and just when it comes up to 15 seconds, if I can watch my watch at the same time, coming up in a few seconds now, we'll shove it on now. Whoops, missed it. Missed it. Hang on. Hang on, we're a bit out here. Here we go. I'll do this at the same time. Go. And you can see here we're rotating around here. That's doing about one full revolution. That's 100 there, and we're coming up to 15 seconds about now. So we'll take that off. That's about 130 RPM. So it's in 15 seconds. So we're looking at double that, which is it's 260. That's 580 RPM. This particular machine is running it at the moment. I'm Mark Wilson and the Engineering Heretic, and thanks for watching.